According to the National Electrical Code, specifically sections 200.6 and 250.119, grounded conductors and equipment grounding conductors in a multi-conductor cable must be identified using specific colors. This identification is typically achieved by marking the exposed insulation with tape or adhesive labels. The key colors for this purpose are white or gray for grounded conductors and green for equipment grounding conductors. It's important to clarify that this requirement for color coding isn't solely applicable in situations where qualified personnel exclusively handle the maintenance and supervision of the electrical installation. The code mandates this identification method for all multiconductor cables, irrespective of who is responsible for maintaining the equipment. The underlying reason for this universal application is to prevent confusion between grounded, grounding, and ungrounded conductors. Proper identification is paramount for safe and accurate connections during both the initial installation and any subsequent maintenance work. Consider an institutional setting, such as a school, hospital, or large office building. In these environments, it's possible that maintenance tasks might be carried out by individuals who aren't formally qualified electricians. In such cases, the importance of clearly identifying conductors becomes even more pronounced. Incorrectly connecting a grounded or grounding conductor to an ungrounded conductor can create significant electrical hazards, including the risk of electric shock and fire. Therefore, even or perhaps especially in an institutional setting where qualified maintenance personnel might not always be present, adhering to the color coding requirements outlined in sections 200.6 and 250.119 is essential. Using tape or adhesive labels to mark grounded conductors as white or gray, and equipment grounding conductors as green ensures that anyone working on the electrical system can readily distinguish between these conductors and avoid potentially dangerous misconnections. To elaborate further on the specific requirements within the National Electrical Code, Section 200.6 focuses on the means of identifying grounded conductors. It stipulates that for conductors smaller than number 6 American wire gauge, or AUG, the installation must be white or gray. However, when dealing with larger conductors, number 4 AWG or larger, the grounded conductor must be identified by a distinctive white or grey marking at the termination point. This marking can take the form of white tape, white paint, or other effective means of identification. Section 250.119 addresses the identification of equipment grounding conductors. It mandates that the insulation of an equipment grounding conductor must be green or green with one or more yellow stripes. This color coding serves as an immediate visual cue, allowing anyone working on the electrical system to quickly identify the conductor that is responsible for providing a safe path for fault current back to the source. It is critical to note that the use of green wire for anything other than an equipment grounding conductor is strictly prohibited by the National Electrical Code. This is to prevent any confusion or misidentification that could compromise the safety of the electrical system. Now let's consider the practical implications of these code requirements. When installing or maintaining electrical systems, it is crucial to carefully inspect all conductors to ensure that they are properly identified. If the insulation of a conductor is not clearly marked with the appropriate color, it must be re-identified using tape or adhesive labels. It is also important to ensure that the markings are durable and readily visible. Over time, tape or labels can become faded, damaged, or detached. Therefore, it is necessary to periodically inspect the markings and replace them as needed. In addition to the color coding requirements, it is also important to follow other best practices for electrical safety. This includes always de-energizing circuits before working on them, using appropriate personal protective equipment such as gloves and safety glasses, and carefully inspecting all connections to ensure that they are tight and secure. By adhering to these practices, you can significantly reduce the risk of electrical shock, fire, and other hazards. It's also beneficial to understand the fundamental purpose of grounding and bonding in electrical systems. Grounding refers to connecting the neutral point of an electrical system to the earth. This creates a low impedance path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and quickly to energize the circuit. Bonding, on the other hand, involves connecting all metal parts of an electrical system together to create a continuous electrical path. This ensures that all metal parts are at the same electrical potential, which reduces the risk of electric shock. The combination of grounding and bonding provides a comprehensive safety system that protects people and property from electrical hazards. Now let's delve into some specific scenarios where proper identification of grounded and grounding conductors is particularly important. Consider a situation where you are adding a new circuit to an existing electrical panel. In this case, it is essential to carefully identify the grounded and grounding conductors in the existing panel and connect them to the corresponding conductors in the new circuit. Failure to do so could create a ground fault, which could trip the circuit breaker or, in more severe cases, cause a fire. Another scenario to consider is when you are replacing an electrical receptacle or switch. In this case, it is important to carefully note the wiring configuration of the old device before disconnecting it. This will help you to ensure that you connect the wires to the new device in the same configuration. If you are unsure about the wiring configuration, it is always best to consult with a qualified electrician. In addition to the above scenarios, it is also important to be aware of the potential hazards associated with working on electrical systems in wet or damp locations. Water is an excellent conductor of electricity, so the risk of electric shock is significantly higher in wet or damp environments. Therefore, it is essential to take extra precautions when working on electrical systems in these locations. This includes wearing rubber gloves and boots, using ground fault circuit interrupters, or GFCIs, to protect circuits, and ensuring that all electrical equipment is properly grounded. Furthermore, it's crucial to understand the difference between a grounded conductor and an equipment grounding conductor. The grounded conductor, often referred to as the neutral, carries current under normal operating conditions. It provides a return path for current to flow back to the source. The equipment grounding conductor, on the other hand, does not carry current under normal operating conditions. Its sole purpose is to provide a low impedance path for fault current to flow back to the source in the event of a ground fault. The equipment grounding conductor is connected to the metal enclosures of electrical equipment, such as appliances, machinery, and electrical panels. This ensures that if a fault occurs, the fault current will flow back to the source through the equipment grounding conductor, tripping the circuit breaker, fuse, and energizing the circuit. It is important to note that the grounded conductor and the equipment grounding conductor must be kept separate except at the service entrance or the source of a separately derived system. Connecting them together at any other point in the electrical system can create a dangerous condition known as a neutral ground bond, which can cause current to flow on the equipment grounding conductor and create a shock hazard. To summarize, the proper identification of grounded and grounding conductors is essential for electrical safety. By adhering to the color coding requirements outlined in the National Electrical Code and following other best practices for electrical safety, you can significantly reduce the risk of electrical shock, fire, and other hazards. Remember to always de-energize circuits before working on them, use appropriate personal protective equipment, and carefully inspect all connections to ensure that they are tight and secure. And if you are ever unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. They have the knowledge and experience to ensure that the work is done safely and correctly. Furthermore, it's beneficial to stay updated on the latest revisions and interpretations of the National Electrical Code. Electrical codes are regularly updated to reflect advancements in technology and address emerging safety concerns. Familiarizing yourself with these updates will help you to ensure that your electrical work is always in compliance with the current standards. Consider attending workshops, seminars, or online courses to enhance your understanding of electrical codes and safety practices. These educational opportunities can provide valuable insights and practical skills that will help you to become a more competent and confident electrical worker. Also, remember that electrical safety is not just the responsibility of qualified electricians. Everyone who works with or around electricity has a role to play in ensuring a safe environment. This includes homeowners, business owners, maintenance personnel, and anyone else who might come into contact with electrical equipment. By educating yourself and others about electrical safety, you can help to prevent accidents and save lives. In closing, the principles outlined in sections 200.6 and 250.119 of the National Electrical Code are not merely suggestions, they are fundamental requirements designed to protect individuals and property from the inherent dangers of electricity. Compliance with these regulations is paramount, regardless of the setting or the qualifications of the personnel involved in maintenance and operation. The consistent and accurate identification of grounded and grounding conductors is a cornerstone of electrical safety, ensuring the reliable and safe operation of electrical systems in all environments.